Hello, Calculus. In this video, I want to show you how to use the TI-84 CE edition, or even TI-84 family of calculators. For the most part, this will apply. How to use those to find the derivative of a function and its tangent line. So let's consider this question. Find the tangent line to f of x equals sine of x plus ln of x, or called the natural log of x, at x equals 3. Well, if you've been following along with the calculus lessons, you're going to know how to find this derivative. So, f prime of x will equal the derivative of sine is cosine, so cosine of x, plus the derivative of the natural log is 1 over x. So I know that my derivative is this, and I know that f prime of 3, if I want to evaluate that, is going to equal the cosine of 3 plus 1/3. Now, again, I have not found the tangent line yet, but we'll use technology to help us with that. But remember that for the tangent line, I need a point and a slope. So this is my slope here, which is nice. My point, I need to get from the original function, so f of 3, which equals the sine of 3, plus the ln of 3. So really, my coordinate point is actually 3, comma, I'm going to go ahead and put this in parentheses, sine of 3 plus ln of 3. So guys, just really quick, my tangent line is y minus the parentheses sine of 3, and I need those parentheses because I'm subtracting this quantity, equals my slope, which was, this is kind of weird, but my slope was cosine of 3 plus 1/3, my m, times parentheses x minus 3. And so, I mean, really, there you go. There's the tangent line. But let's say that I want to do this process not with, not by hand here, but with the calculator. Let's go through this here and let's check it out. So if I bring up the 84, what you'll see here is a blank screen. But let's get some things on it. So this is kind of nice. The calculator under math, if you click math, you'll see a number 8 is the nth derivative. And we're going to hit 8 on our keypad. It's going to bring up this nice little template for us. And so what I want to do is actually, I accidentally typed in that. I want to put an x there. I want the derivative with respect to x. And I want to type in what we had. We had sine of x there, and over. Oh, let's go back here. We got to close a parenthesis, actually. Sorry, and then hit plus. Got to type in ln, which is right here on the left, ln of x. Then I'm going to hit over, and I want it to be at the value of 3. Hit that, I get that. Now let's see if that's the same, because I said it was cosine of 3 plus 1/3. I think it's what we had. So plus 1 divided by 3. Let's see if that's the same thing. And it is. You'll see I get a little bit more decimals on that one. That doesn't matter. You get the same idea. All right, now, you'll notice that actually the difference comes in a little bit later here, which is, I'm surprised there. They could be using a different algorithm to find the derivative at 3. And so the preferred value, though, is going to be down here that I typed in. That is definitely the more precise value. It looks like the computer is using an algorithm here and its approximations getting a little bit off there. So that's okay. It's still going to be accurate to within 3 decimal places, and that's what we're really concerned with, especially on the AP exam. But let's go ahead and go to the graph screen. So that's one way to do that. You can use the template, or let's go ahead and graph this and see what the calculator will do. So I'm going to graph the sine of x, parentheses, plus the ln of x. Let's look at the graph of this. My graph screen. It's kind of a neat little graph. Now, one thing to be mindful of, there's actually an asymptote here, and it's going to go down forever. So the 84 does not render it perfectly, but it will keep going down here, and there's an asymptote at 0. So just be mindful of that. But we're interested in 3, so that's over here. So let's see if we can do this. So one nice thing with the calculator is it will do the derivative on the graph screen. So hit second, calculate. And what you're going to do is you want dy dx, number 6. Click that, and it's going to say, okay, where? Okay, it's like kind of a blank spot. I want you to type in on the keypad, type in 3, hit enter. And it should bring the cursor over there, and you're going to see that it gives you the derivative, negative 0.656659, which looks familiar to what we had on the original screen. And here it gives you the x coordinate as well. The x is 3 and the y is this. This is very nice because from there we can actually plot the tangent line. So let me see if I can remember some of these values. I have negative 0.657. So I want 657. And then I need my 1.240. So 1.24 is what I need. Okay, let's see if we can do this. I'm going to go back to my y equals. And I'm going to go ahead and put point slope form, a little bit modified version of point slope form, but negative 0.657 parentheses x minus 3 parentheses plus, if I remember correctly, 1.240. We went 3 decimal places on the AP, but the computer will kick out we'll get rid of the 0. But let's go ahead and graph that. Let's look and see where that goes. And there we go. And let's see, again, let me bring up my calculate. Let's hit second calculate. Let's bring up the derivative at 3 again, just to compare. 6. And then I'm going to type in 3 on the keypad, enter. There you go. There's where that tangent line is. It's going right through that point. We could zoom in a little bit probably on it to see it a little bit closer, but there you go. So we got a tangent line graphed at that particular point. Remember, the derivative is actually the slope of the tangent line. It is not the tangent line itself. They are related. The tangent line is related to the derivative because the slope of the tangent line is the derivative. But be careful. Remember, the derivative gives you the slope of the tangent line. And so at any particular point that you are looking for. So there we go. That is derivatives using the TI-84.